Hope you see the slide. Is it? Okay. Hope you see the slide. Is it visible? Please unmute and tell the slide is visible for you.
Yes, ma'am.
Okay.
Yes,
So
ma'am.
yes. Okay, thank you. So we are going to actually multi-threading is the topic we already heard sometime. Then the last class we already heard about multi-threading.
Yes, ma'am.
Okay. Fine. So multi-threading is the concept of the process when an OS that will be shared for multiple processes. Each process is divided into multiple threads. Okay. So programming or a lightweight subprocess, it will be called a thread. Thread is supported by using thread classes that is supported the thread. Then thread will be or thread class it have its own constructors and also the methods and thread is have some types of methods it contain, and it always extends some other classes and also implements runnable interface. These are the different functionalities of the or different methods which we are or which supports the thread classes, which support the thread classes for implementing multi-threading concept. Multi-threading means multiple threads will operate simultaneously, concurrently, multiple threads will operate. So thread is an independent process which will not affect other threads. So if an exception or an error that will occur inside the thread when it is going to run, so the exception will not affect the next part of the thread or next thread. So thread is an independent lightweight sub-process. Then these are the different methods which support thread classes and life cycle of thread. It contains 5 states. New is the starting state or the new is the new thread that is created. When the thread it will invoke the start function, it will be the thread will be created. So at the time of thread creation, the thread will automatically generate or automatically call the function run function to activate the thread. Run is the function which we declare inside the runnable interface. So runnable interface is used to create threads and define their behavior. So what will be the thread doing? What is the execution or what is the implementation of that particular thread that will be implemented by runnable interface? So runnable interface, it contain only one method regarding the thread operation, and automatically when a thread is started by using the start method, it will be automatically invoked by using runnable interface. So which class that going to start the thread, that will be extends the thread class and also it implements the runnable interface. So it will be separately be written inside the runnable interface. One method, run method will be there. That method we can override, and this return or implementation method which we invoke, which will invoke at the time of thread will be start. Then blocked means or waiting means it will be suspended for some times. Then at this waiting time will be denoted or notified at the by using timed waiting. Then terminated is the thread ending the process. So when the thread is running or activating, it contains two methods. One is runnable and another one is running. Runnable means it is in the ready state, it is going to run, that is the indication of runnable. Running means when the state of the process or thread it is moved from runnable to running state, that is the indication of running state of the current thread. Blocked or waiting, that means it is not permanently suspended or permanently terminated, it's waited for some times. And this waiting time also which we indicated by using some timed waiting or a milliseconds, which time period that particular thread should be wait, that will be indicated by the sleep method. Sleep is used to implement the timed waiting concept or timed waiting state of a particular thread. Termination, it will be indicated by the thread that which thread we are created, that dot stop or that dot terminated. That is the indication, that is the method which we are using to terminate the particular thread. Then thread states, what are the different thread states that should be mentioned inside the thread state enum constant set or with using enum keyword. Get state, that should be written the current state of the thread, and new runnable blocked waiting, timed waiting and terminated. These are the certain weights of states of the thread which will be returned at the method which we called like which classes which support thread class which support by using that class dot state or that class dot get state, that will be returned the current state of the thread. Then multi-threading is the Java is one of the special or powerful feature that will be available in the Java program to allow concurrent execution of two or more parts of the program with the maximum utilization of CPU. So that program or the executable part, it will be called the thread. So this thread or multiple thread can be generated from a certain processes, and threads can be created by using extending the thread class. The thread class, whatever the class which are going to implement the thread concept, that class is extended the thread class. And also when we want to implement the run method or to activate the thread, which we need the runnable interface, so we need to implement the runnable interface. The class is going to extend and the interface we need to implement. So Java thread, it will be created or extends which class java.lang.thread. This is the package, and java.lang, this is the package which we are using, and inside that package dot thread is the class which supports Java thread operation or multi-threading concept. Then one class overrides run methods. The thread, it will begins activating or it will be functioning from inside the run method also. So when a function or a method or when we create one thread class object, by using that object, when we invoke the start method, that is object dot start, this is the indication for the thread creation. At the time of start execution or the execution of the start method, it involves the run method by using that particular object also. So it will be activating. That means from the runnable state to or the ready queue to it will be moved into the ready state. That is the concept called a run method. It will automatically generated when the thread is created, or the thread object or thread class object, it will be created one object. By using that object, it will create the start method or invoke the start method. At the particular time, the run method, it will be invoked. So main functionality of the runnable interface is to implement the functionality of the thread. That is the functionality of the or the implementation for the of the runnable interface. So it will be belongs to which class? Runnable is the class which is java.lang. It belongs the packages. Then the runnable or runnable interface, it will to create or implement what are the or what will be included inside the running method or run method, that will be invoked by using this implementation keyword. So we need to create one runnable interface. We need to create one interface such as runnable. So we all know how to create one interface. The same as the class, we need to create one interface specially. Then inside that interface, we need to create one method, only this name also. Name only we could write inside the runnable interface. Then inside the Java program, another Java class that will be thread will be working, or that class which we known as thread class. And that thread class, it's contain its own constructors or other methods, and also that class particularly implements to the runnable interfaces. So by using the thread class, we used to invoke the start method by using its own instances. Instance means the object of the corresponding class. And by using that object, we also, at the time of start invocation, it automatically runs the it automatically calls the run procedure with the implementation details. Then it execute a thread that execute the code written in run. Then what is the invocation? What is the activity that will be belong to run method that will be executed? This is the concept called runnable interface. So here one program that is used to how this runnable interface that will be working. So one class which is used to create the main function and another class which is used to implement runnable. So for this program, we have one function, one interface which is called a runnable. Inside that runnable, the name or runnable interface, it will include the property of called a run. This is for the threading concept. So inside the run, for one class, runnable IMPL, runnable IMPL, that's the name of the class which is going to implements runnable. This is the keyword which we are used to interface runnable to be inserted inside one particular class. And inside that class only, we could implement the details or we could write the implementation detail of this particular interface. So public void run, this is the method. Inside that system.out.println thread current thread dot get name. We already learned some functionality or some methods which the thread classes support. So get name is the method which is used to return the name of the current thread. That is the indication of the dot get name. Here thread the dot current thread. This means that already we created or the thread class which we are going to extend or which we are going to insert the properties of the thread class, and by using that thread class, what is the current thread's name that will be written. So plus operator is used to concatenation operator, then executing run method. So this is the concept called which thread is newly created, that thread name should be returned. With that name, we concatenated some statement executing run method. Okay. So for to activate or invoking the runnable interface or the public class runnable IMPL, we need to insert one class with the main function. So inside that class name is runnable demo. Then main function, inside that main function, we output console, we printed some statement like main thread is on the main function, which part of the code that is the main function. Inside that main function, for running or executing that particular program part, we created one thread, is it? So that thread dot current thread dot get name that will be returned at that place. And by using that thread, we created for the thread class, we created one object. This object, by using this object only, we could invoke the function or we could invoke the method start method to start the thread, is it? By when we create this thread, at the time only the runnable interface or that will be or it will be when the object is initialized. The statement thread T1 equal to new thread of new runnable demo, then new runnable IMPL. What is the meaning of this? Thread T1 equal to new thread means T1 is the object which we are going to declare as the object of thread class. equal to new thread, is it? Inside that parenthesis, we invoke the constructor, is it? When an object is created, at the time of object creation and object initialization, the constructor, the default constructor that will be automatically invoked. So new runnable demo means runnable demo, it contains its own constructor that will be invoked. New runnable implement, that means another class which we are which we already declared runnable IMPL. So that class also, that constructor also invoked. And by using that T1 object, we called the method start, which is going to start the thread. What is the current thread that should be invoked? And also, at that particular time, the run method will automatically invoked. So, after this start, the run method will be that, is it? So, start is the indication for the starting thread, or thread will be initiated, or thread will be started. Then run method is to activate or to change the thread into running stage. So in the run method, we could write thread dot current thread dot get name, then executing run method. So at that runnable interface or runnable IMPL class, inside that run, which thread is created, that thread name that will be returned and concatenated with the executing run method. This is the feature or functionality of the runnable interface demo. So after executing this program, this will be the output. I already given this, but here I am going to run this program. I'm going to present one window again. And this is the compiler window. Okay. So here we, so this is the program I just copied about. That is one runnable implementation class and also runnable demo class. And inside that main function will be the, inside the main program, that is the current program that will be running. So at that time it will create one method, or it will create one thread, and that is the thread called here main thread is concatenation operator. Main thread is, that is the statement inside the double quotes, and thread dot current thread get name. That means that what is the, which one of the current thread that is generated, its name that would be returned. That is the main is the name of that current thread. And also thread T1 is the object which we are going to declare, and it automatically invoke the constructor runnable demo and runnable IMPL. Then T1 dot start. Start is the another method which is used to thread could be invoked or initiated. At the time the thread is moved on to the run method, this will be implemented at the runnable interface or runnable IMPL class, which implements runnable interface. And inside the run method, it contains some of the execution statement. At that time, another thread will be created, or that will be opened. So here thread dot current thread dot get name, that is thread 0 that is created. Then with the concatenation, we included executing run method. So thread 0 is executing run method. This is the concept called runnable interface. Okay. So here the slide, hope you see the slide. Then thread class, which is used to declare the thread and for the initiation of thread. Runnable interface, which implements the thread class and which contain the run method. And inside the thread class, we can declare any number of constructors and any number of methods. Runnable interface, which only includes run method only, and the yield, interrupt, etc. other methods of the thread supporting methods which will not appear inside the runnable interface. It contains only one method, run method, which is used to activate the thread only. So what is the concept of synchronized keyword? So synchronized keyword is another method is used for the multi-threading concept for to avoid when a concurrency occurs. In OS we hear the term race condition. Race condition means when we concurrently operated multiple processes together, when one process have a certain change that should be affected on the next process. If it is not happened, one process that will be one process that is executed, it is not updated actually at that time, the second process will retrieve or use the wrong value. So that is the concept called a race condition. That means, example for the race condition in OS we already studied. In Java also, when multiple threads are operating, so when two values that depends, or before the thread, for the thread creation, we created one thread for to manipulate A. When we create another thread for manipulating B, this is the two variable which we are. These are the two variables which we used inside the Java program. Then one type of transaction or calculation which we performed before the synchronization mechanism. So when the values got some values in the S A inside A and some values inside B. Then after the thread creation, both threads are randoms or random number of times these calculations will be performed at a thread A and thread B. Both are concurrently executing. So if it have or may chance to occur some errors. That is inconsistency of data. That is the problem in data integrity. That is random number of times this code or this calculation that would be performed, the A value may be changed or B value may be changed. So after receiving or after we are trying to read the value of A and B, it will be changed. So it will occur the error while one constant value that we need to capture or that we need to retrieve from A or B. This is the situation called race condition. Is it? So avoiding this race condition inside the Java program or between the threads. Between threads means threads are independent process, so it will be operated separately up to that period, or in this condition also, or in that situation also, the thread will have chance to or may have the chance to change the value of particular thread variable. It will make the inconsistencies of data when we need to further or future need for that particular variable. So these are the condition which will occur race condition. To avoid this race condition between threads, which we use the keyword called synchronized keyword. So inside the method, or what is the method which we are going to randomly do the calculation after the creation of thread class by concentrating some other variables. At that method, when we declare that method, we used the synchronized keyword. So this, after implementing or after incorporating synchronized keyword, the value may not change at any time of random calculations or inside the thread. What are the concurrent operations or the or random number of calculations that will be happened, the value of these parameters or variables or threads, it will not be changed. Before whatever the value inside these variables or threads, that will be maintained by using or by using the method or keyword synchronized before a method, which will going to happen random number of calculations. Thus that is the idea behind synchronized keyword, is it? So here one program I am going to explain that. So here the okay, here This is the function or classes which we used. So thread inside that program, which means that here one transaction or we are using the thread concept and thread for implementing the thread or thread operations inside the or to activate the run method or which we are going to implement the run method, we are going to implement the runnable interface. This is not doubt, is it? So for that, public class main implements runnable. Inside that runnable, then we created one main function and we assign some values into the variable a equal to 100, b equal to 100. Then we added these variables a plus b and it will be printed inside the main function. Then we created two threads, thread 1 and thread 2 for the thread classes. It contained the construct of new main, that is the class main. It contained automatically initialize the variables a equal to 100 and b equal to 100. That is the constructor, that is the aim of the constructor. Each thread which we given this a equal to 100 and b equal to 100. And by using this thread 1 and thread 2, we initiated the thread or started the thread by using the keyword thread 1 dot start, thread 2 dot start. Each thread concurrently it will start. Then it will implement the method or after the finishing or when one thread is finishing or it will be indicated or when a error occurs or an exception occur inside the thread 1 and thread 2 concurrently or concurrent processing, it will catch one exception, interrupted exception. It will whatever the exception that will occur inside the main function that will be printed. So that will be handled. That is the concept of try catch exception handling. Then system.out.println, we done that a equal to a plus b which we printed. Then when we start the thread, thread 1 dot start, thread 2 dot start, at the time only the run method which will be called. Inside that run method, we created one random number of generations. We need to calculate the function transfer. So choose a random amount of transfer. We need to implement the method public static synchronized void transfer. This is the method which we are invoked random number of calculation inside the variables a and b. So before the method transfer, we given the value or keyword synchronized, is it? So inside that transfer, we checked that if a greater than b, a equal to a minus amount, then b equal to b plus amount. If a is not greater than b, it will calculate a equal to a plus amount, b equal to b minus amount. This type of random number calculation or random number of transfer, that is a will be changed or b will be changed, that will be occur inside the transfer method, is it? So here we are using one keyword, it is called synchronized. So what will happen inside this by using this synchronized method, what will happen? So here I am going to run this program. So the sleep time, that will be the delay of thread that will be created. So by using this a equal to 100, b equal to 100, we already given the values a plus b total before 200. After creating thread 1 and thread 2, and inside that thread 1 start, thread 2 start, which we invoke the function transfer, and before the transfer we used the synchronized method. So that only the variables value a and b not changed after a random number of calculation inside the transfer method. How we check that? We deleted this synchronized keyword. What will happen inside this transfer method? So here total before 200, after executing the thread, random number of calculations it will be happened. So total before 200, but total after the thread implementation inside the transfer method without a synchronized keyword, the thread will be random number of times it will be calculated, and it will be generated a random number. A will be changed and B will be changed, then A plus B is also changed. Then again that will be running, so it will get another value for the total after. Total after equal to minus 473. That is, no other values or the free from previously we get got the 873 value. This is the minus 473. That is the random number of time math dot random, that will be the transfer function that will be invoked, and a equal to a plus amount, or b equal to b minus amount, or a equal to a minus amount, or b equal to b minus amount. This will be randomly changed and the value should be changed. And while we putting the synchronized keyword inside the transfer, so whatever the random generation that is happened to A and B, or thread 1 or thread 2, it will remains the output same. That is called a process synchronization or thread synchronization. Whatever the concurrently or concurrent processing that is happening, but the thread value, it will not be changed by using the synchronized keyword. So here in the example, the transfer method may cause the values A and B to be modified and by another thread in between operations. So the total amount of variables A plus B that need to be changed without using synchronized keyword. If we are using synchronized keyword, the concurrent, whatever the concurrent operations that will be occurred inside the multi-threaded applications, we can synchronize the operation, and the data inconsistency or data integrity, that will be data inconsistency that could be maintained, and data integrity that will be maintained. So we could eliminate the condition, raise conditions between the threads by using synchronized keyword. Okay, so hope you understood the concept. That is multi-threading concept and runnable interfaces and synchronized keyword. Then I'm going to share one screen with the QR code. Please do the MCQ. Okay. Into, where is the Socrates? Into, just a minute. Okay, this window, hope you visible this window for the MCQ. Okay, you scan this QR code and do the quiz. Okay, do the MCQ. Is this QR code is visible? Please unmute and tell the slide, the QR code is visible or not. No one is responding.
Ma'am, it's visible, ma'am.
Okay, you just scan it and do the MCQ. Okay. Attendance I will put after looking the attendance tracker. Okay. Please do the MCQ. I hope all you got the QR code, is it?